There are 40 billion Earth-like planets in the Milky Way alone, yet the observable universe remains deafeningly silent. Finding just one other intelligence out there would alter our perspective, snapping us out of our earthly quarrels by proving this massive expanse isn't entirely dead. But because extraterrestrial civilizations could have started millions of years apart, we face a massive hurdle. As we point our radio telescopes at the sky, we don't actually know what to listen for. Are we searching for cavemen or gods? To figure that out, we have to look inward. Right now, our sample size for an intelligent, world-building civilization is exactly 1. So we have to extrapolate our own defining traits, our deep curiosity, our intense competitiveness, and our relentless greed for resources. Being in perfect harmony with nature is a nice thought, but it doesn't build irrigation systems, gunpowder, or global supply chains. The species that successfully take over their home planet are the ones that aggressively extract resources and clear forests to fuel their growth. And if alien species are bound by the same laws of physics we are, then there is only one universal, measurable metric for that physical progress: energy use. This means that to find sprawling alien empires, we shouldn't be looking for biological signatures. We should be searching the cosmos for the physical footprints of how they consume power. You can trace the entire arc of human history strictly through how we extract that power. We started with our own muscles, learned to control fire, captured the kinetic energy of wind, and eventually learned to harness the dense, buried energy of dead plants. This chart plots human population and energy consumption from 1800 to 2015. Over those 2 centuries, while our population increased 7-fold, our energy consumption skyrocketed by 25 times. To categorize this kind of exponential growth, astrophysicist Kardashev developed a scale to rank civilizations entirely by the magnitude of their energy consumption, separating them into distinct tiers that range from cave dwellers to beings that rule over galaxies. Right now, humanity sits at about level 0.75. We haven't mastered our planet yet, but we've relentlessly altered its surface, carving out massive open-pit mines, stripping mountains, and changing the chemical composition of our atmosphere. If we manage to survive our current technological adolescence without destroying ourselves, becoming a full Type 1 civilization, one capable of harnessing all the available energy on Earth, is our inevitable next step. But an expansionist species won't stop there. The transition to a Type 2 civilization requires pushing out into the local solar system to build orbital infrastructure, establish colonies, and strip mine neighboring planets for raw materials. Eventually, their demands will scale so aggressively that they take on the ultimate engineering project: building a Dyson swarm, a massive web of solar collectors designed to capture the entire energy output of their home star. With the limitless power of a star at their disposal, a truly greedy civilization will look outward again. The leap to Type 3 demands crossing the vast, unforgiving distances of interstellar space to colonize and harvest entirely new star systems. This creates nearly impossible logistical problems. Over travel times that take thousands of years, how does a sprawling empire maintain a shared culture, or even a shared biology, across the silence of deep space? By the time they solve those problems, a Type 3 civilization would be essentially godlike. They might manipulate dark matter or bend the laws of physics, viewing human beings the same way we view bacteria on an anthill. Some scientists even theorize a Type 4, or a Type Omega, whose influence spans entire galaxy clusters, possessing technology so advanced it borders on the ability to engineer universes themselves. As energy consumption scales up to these galactic levels, a civilization's physical form, their logic, and their motives become entirely unfathomable to a primitive Type 0 species like us. This brings us to a stark logical conclusion. If Type 3 empires exist out there, their sheer scale should make them impossible to miss. We should see the thermal signatures of harvested stars and remnants of colossal ancient engineering projects. Yet, when astronomers look up, they find absolutely nothing. There are no dimming stars wrapped in solar panels, there are no scars of great interstellar wars, and zero evidence of galactic empires anywhere near the Milky Way. But our ability to detect them is deeply flawed. A civilization that simply isn't blasting radio waves into space could be living right next door in the Alpha Centauri system,
and we would have no idea they were there. Even if they were deliberately transmitting, our physics work against us. After traveling just a few light years, artificial radio signals degrade and scatter into pure background noise, indistinguishable from the natural static of the universe. The most probable and strangely reassuring reality is that the galaxy simply doesn't have any gods. It is likely left exclusively to intermediate civilizations, peers somewhere between Type 1.5 and 2.5, who are only just beginning to look outward. Or perhaps we are just too immature to imagine that true progress doesn't actually require greedy, endless expansion.